Welcome back. We're back in my personal Sunn Model T. It's a nice, beautiful day outside. The sun is out, which means it's a great day to be in the garage with the Sunn amp. Although that would be the case if the weather was very bad as well. Okay, so following up from last time, we are going to be replacing these two bias caps. And then also this guy, which I found, did not know there was a problem. This is kind of the incentive for doing any work on this amp. But this is a plate resistor. Going to replace this. And I actually got resistors to just go ahead and replace all these. I'm kind of thinking I can potentially reduce the height on some of these to kind of lower the amount of fulcrum these have for wiggling around in the amp and still maintain some good proper airflow and ensure that we don't get a similar situation to this where basically the weight of the resistor wiggling around is going to break off the leg at that juncture point. Also, you want to be careful with these kind of resistors. If you bend them too close to the actual body, they are more prone to that breakage. Like, look at this guy, how close that is bent. Doing that bend puts a lot of stress on that joint, the junction between the actual resistor body and the leg. And that's usually what causes these breakages, along with some vibration. Now, I am now realizing there's some other work we could do in this amp, which I did not order parts for, so we'll probably do one more follow-up at some point down the road. But these giant Sprague Atom, these are the power supply filter caps. These are about the most expensive capacitors you could have to replace in an amp these days. They're about $30 a piece at time of this video. And I thought to look up the date code on these after actually doing this video, or the first one of these videos. I apologize, this is upside down, but 0335 means these are from 2003. Which puts them at about coming up on, are we in the 35th week of the year? I don't know. We're coming up on 22 years old with these. So they're, arguably fine for now, but for an amp of this caliber, for the amount of use I give this guy, it's worth throwing another $60 at parts. And, that's the same reason I'm going to be changing out these resistors as well. It's worth just getting this thing tip-top shape, knowing it's going to run and sound its best. Okay, so we're going to dive right in with that work. I'm going to change out these two caps, change out these resistors. We will check the tubes on the tube tester, bias the tubes, and then just do a kind of, voltage check, minimal sound test to make sure everything's good. And assuming everything's good, then we'll do a full-on sound demo of this amp for the next Saturday Sound Check video series. All right, let's go ahead and get into it. Okay, we're going to start by doing these two capacitors. It looks like the positive legs are going to this side and both connecting to this pin and this pin. This leg is going through. So I'm going to remove the solder. I'm probably going to clip these and then remove all the solder from those two pins on the tube socket. And then go ahead and pull the other part of the leg out. And then they're both going back to, looks like different sides of this guy. And we're going to use a little bit of silicone to attach these. It's already that way. But we'll want to make sure that these are secured to the chassis via some kind of adhesive or silicone. For the same reason that, we want to reduce mechanical strain from vibration on things like these resistors. Okay, let's see what we can do. And I got these nice new F&T caps, 47 microfarad, 250 volt, to put in their place. One other note before we dive in here, but on the last video I mentioned that we have a bias and a hum balance here between these two. A couple quick identifying ways to know which is which from the underside of the ampere. The hum balance has these two equal sized resistors across it, which is a good indication this is the hum balance, but then also the direct connection of the capacitors, which are reverse biased, the negative going to the side that you expect a positive to go to. It's a good indication of this being the bias. So because this is such a tight area, I'm using just a wooden kind of chopstick tool to scrape away some of that glue that was in there. We don't want to use a screwdriver or something with a metal tip that it's going to scratch up the chassis on something. But we can use something that's non-destructive or relatively soft just to get the last of that up. Okay, let's get the new one in place for that side. Oh, actually, I should remove this first. Let's see what we can do there. Okay, so I have this terminal and this terminal cleaned up for, let's see, this is where our first cap is going to go between this point and this point, but then the leg carries over to this socket to connect to the other capacitor. But then this capacitor on this side not only goes to here, but also to this, because these black wires are what carry the bias to the other three tubes. And maybe you can now see what's going on with point-to-point amps. It's not, they're not necessarily easier to work on. They are nice because everything is out in the open. But all of the routing that would be done by a PCB or by wires on a tag board or something like that, but beneath that, are instead done with the legs of components. So I already disconnected from this terminal. I'm also going to pull this leg out so that we're staged for this first cap to connect to here, here, and here. I will solder this point and this point, but then wait to solder this terminal until I can get this second cap in, which also connects back to here. And I believe that's even going to 2 points. So that's connecting to here and to the pot, to the bias probe point, as well as to the bias pot. So this cap is connecting to 1, 2 on this side, 3, 4 junction points. The cap that was here is connecting to 1, and then on this side, 1, 2. Okay, so just a little heads up. I'll show you what that looks like in maybe sped up time, but that's where we're at. Okay, we're going to use some of this super fancy electronics grade sealant adhesive. Just because why not? The Model T deserves the best. And I've kind of staged the capacitor to make sure that the legs are going to fit the way we want them to. But this guy barely fits in there, so lucky that it will. Let's see how this goes. I'm just going to add the slightest, tiniest bit of this adhesive. We really don't need a lot. Okay. Like that is arguably too much, but should be okay. So now the fun part is going to be to weave this leg through. Get this pressed into place. Okay. Making sure we're not contacting any other terminals on the tube socket or anywhere else. This one is going to go through the bias pot. Along with this white wire. I might trim just a little bit back on this guy before we solder. Okay, so we're in place. I'm going to clean up that little tiny dab of sealant that got on the bias pot. Not going to hurt anything, but just to clean it up a little bit. Okay, so at this point, we will clip some of our excess leg here. Get this wire in place. Make just a little bit of a hook for a mechanical connection. And let's go ahead, we're going to solder this one, but leave this guy in case we need to wiggle this around as we're connecting the other side of this one. Okay, that looks good. So now before soldering this side, I'm going to remove this capacitor, which means we need to remove this leg. And I basically wanted to do this so I didn't accidentally confuse these points. My memory is not always great for this stuff. And also, it is one of those things where you could be in the middle of this and think like, oh, it's easy. I just need to connect this here and this here and this here and this here and this here. But then next thing you know, your phone rings and you walk away. And then you get distracted, you have to run out the door, whatever. And next thing you know, you're coming back to this amp the next day. You don't want to set yourself up for a situation where you think you're going to remember because you're doing it right this second. But then life happens, something comes up, and all of a sudden you're saying, I don't remember how this goes back together, and have to check the schematic and all that stuff. So that's why I do things this way. Go ahead and solder this point. That wire's secure. This leg is secure. This is staged. This we know where it's going to go because it's right next to that point. So now I'm going to disconnect these points because this area is otherwise clear. Okay, let's do that. Okay, we have the space cleaned out of the old adhesive that was in there. Kind of was wondering, I usually keep old parts, especially from vintage amps, always for customers. I'll return their parts to them. Sometimes collectors want to have the original parts for everything, so it helps maintain the value of an amp that has had typical service done for actually using it. But just joking around in my mind, I was wondering as I was cleaning that adhesive off if a collector would want the original hot glue or whatever adhesive was used for a vintage Sunn Model T included, as I was throwing that in the garbage, not thinking twice about that. Anyways, gonna go ahead and put this capacitor about where it's going to land so that it will be in a good position. We'll route this leg, get a rough approximate route to go to this junction point, as well as right there. Show you a little closer. We already went over this, I think, but I want to connect to this tube socket, or this tube pin, as well as this one with this leg. Positive side over here, and then this leg is going to curve around, go through the red bias test point here, along with these two wires. But that leg will continue through to go to the center leg of the bias pot. Okay, point-to-point amps, gotta love them. Let's see what we can do. Okay, so with something like this where there are a lot of junction points, I like to do a continuity test with my meter, which is the little sound indication, usually associated with the resistance setting. You won't need to see the meter. It's not going to show anything on here other than going from overload, which is open. When it beeps, it'll go to something below 1 ohm. But it's not a bad idea to just check that things are connected where they should. So like this side of the cap is connecting to here, which connects to these black wires, which goes to the bias point for all these other tubes. So that's good. We don't have like a cold solder joint here or something like that. This point is going to here, which goes to the bias pot, which goes to these white and orange striped wires, which I believe are, let's see, did I just lose those? There's one over here, and the other one was in a similar spot. Oh, right here. Okay, so this is all good. And then this guy goes over there, which here's our bias diode coming in from the power supply from the transformer. Okay, and that's kind of just, that's not a necessary step, but I like to double check these things as I go so that you know it's going to be good. Part of the way I was trained to work on this stuff in one of my first jobs was it pays off to take a little bit more time up front, double check things in a way that is documentable and makes sense and logical. Even though it may seem like that takes longer, if you end up having to go back and troubleshoot at the end, it could cause your project to take, 3 or 5 or 10 times as long because you don't know which step that you took has the issue. So doing that little bit of troubleshooting is a preventative maintenance kind of thing up front as you're doing the work can really end up saving you time in the long run. Okay, so bias caps are done. We're going to save filter caps for later when I can order those. And as an excuse to do a little bit more maintenance on this after I've been playing it a little bit, let's go ahead and change some of these plate and screen resistors. Just to give a closer look of what we're going to be doing here, these should be much more straightforward because each side of the resistor is only going to one node. So on this side, they'll be going to a terminal strip that's maybe shared with a wire. And then on the other side, just a tube socket pin that is not shared by anything else. So I may show you one of these in real time and then just bang out the rest. But let's go ahead and dive into it. And these are the 47 ohms are the plate resistors. The, what are these, 1.5K? Yeah. Get that to focus, 1K5 or 1.5K or 1500 ohms. Those are your screen resistors. All of them are 5 watts. I'm just going to change them all out. Why not? We're here. So I don't know if you could see what was going on there, but the thing that took the longest was to get these little pieces of old resistors out of the tube socket and the connection over here. Now these are not from this resistor that I just pulled. So I think what happened is whoever did this work clipped the old resistors out, but didn't clean out the socket pins or the other connections, because these do get oftentimes wrapped around the socket at the factory. It can be a little annoying to do, but you end up with a situation where you have another piece of metal just in there that can compromise your connection to the pin. It's important to always clean your pins that you're connecting to. You at least remove as much of the old solder as possible with a solder sucker or solder braid. For old amps, it's because the solder in there is, 40 or 50 years old. For new amps, it's because maybe you're using a different type of solder. If you're using leaded solder still and it's an ROHS compliant amplifier, they're using lead free, you're not going to get a good bond because you're mixing two dissimilar materials, which have different melting points. Okay, so I'm going to go ahead and get the new resistor in here, and then we're just going to work our way over. I'll show you what the final product looks like. Okay, so we've got a sort of good news, bad news situation here. The good news is I'm going to go ahead and do more of a full restoration on this Sunn Model T. I'm going to order the capacitors here. The bad news is, as I was removing the screen resistor for this tube socket that we were just working on, that we just did this work for the new capacitors, that leg broke off. So we're going to need a new tube socket. Now, these old original tube sockets are riveted in place, so I will probably end up having to drill this out to replace this. Now, I did notice all of these tube sockets are pretty, I don't know if they just use low quality ones on these amps or what, but I'm going to do a little research, see what people commonly do for these amps. It really seems like all of these could stand to be replaced. This is a maintenance thing. I mean, it's, you know, if these tube sockets are going to go at some point, this is an old amp, tends to be played very, very loud on a cab, which means there's a lot of vibration. We at the very least are going to need to change that one. It may be worth just going ahead and changing all of them. I do not like having to drill a hole in a vintage amp, but if it's to simply remove a rivet so that we can properly mount a new high quality belt and tube socket, that seems worth it, especially on an amp that is going to be played a lot. So we're going to stop things here. I'm going to order some parts, do a little research. I was hoping we would be doing a sound check on this amp for next Saturday, as well as moving on to the next Sunn amp to work on, but it looks instead like we're going to be working on this amp next Sunday, pushing the sound check back a week. So, bad news for me. Good news for you guys, because you get to see a little bit more work on this thing. This is going to be a much more thorough restoration series. While I'm in here, I'm going to go ahead and inspect what else we can just go ahead and do. I'm just going to do the full inspection. I'll probably check the date code for the can cap also. Although that's a CE cap, I don't think those have been being manufactured for the same 20 years as these guys. I feel like these were probably originally replaced in 03 or thereabouts, you know, maybe a few years after that. When I bought this amp, I was told that it had been recently serviced, so I'm guessing what they did was replace that single can cap, and that was it, or I guess in these resistors. But yeah, we're just going to go through this thing, get it up and running, make it bulletproof. Okay, so sorry for the delay on actually having this thing ready to sound out and make some noise, but we'll be back next week with more detailed repair on this amp. Hope you all are having a good day. We'll see you for the next video.